Industrial manufacturing operates on a specific mechanical logic of extraction and disposal, a logic that is currently hitting a mathematical dead end. Since the Industrial Revolution, the global supply chain has relied on a one-way system known as the linear economy. The equation is simple. You extract raw materials, manufacture a product, and the end user throws it away. Take, make, and dispose. This straight line was engineered for an era where natural resources were assumed to be infinite, and the cost of extraction was negligible. But today, global commodity prices are increasingly volatile, and virgin resources are becoming scarce. Pulling fresh material from the earth now requires a significant capital premium. At the same time, treating the end of the line as a free disposal site is no longer viable. Landfills have become a source of compounding financial and environmental debt. When raw material costs rise and disposal costs follow, the linear model becomes a liability that slowly crushes a manufacturer's profit margins. This financial pressure is being codified into law. A new wave of global regulatory frameworks has been designed specifically to penalize industrial waste. These mandates include strict carbon taxes and the European Union's Carbon Border Adjustment Mechanism, or CBAM, which applies tariffs based on the emissions intensity of imported goods. These regulations effectively punish the final step in the linear economy, turning waste into a direct tax on the manufacturer's bottom line. Historically, companies responded by treating sustainability as a marketing expense, spending money on tree planting or PR campaigns under the banner of corporate social responsibility. To survive the current regulatory climate, manufacturers have to stop operating in a straight line and physically bend their processes into a circular economy. Resilience in this era requires engineering sustainability directly into the core revenue and cost reduction architecture of the business. Consider a practical example. Siam Pallet is a mid-sized factory that produces industrial plastic pallets for logistics firms. Their single largest expense is virgin plastic resin. Because their production depends on this raw material, their entire cost structure is at the mercy of global oil prices. In their original linear model, they purchase resin, manufacture the pallets, and sell them to clients. After 3 years of heavy use, those pallets break and are hauled to a landfill. As material costs fluctuate, clients simultaneously demand lower prices to protect their own budgets. Siam Pallet is caught in the middle with shrinking margins. Within this linear model, the factory has no control over its raw material supply and no leverage over its clients' price sensitivity. To protect the business, Siam Pallet has to decouple its margins from the volatility of the global commodities market. The company shifts its identity. They stop acting as a simple product seller and begin operating as a life cycle manager for their plastic materials. They introduce a buyback program. Instead of allowing their products to exit the system as waste, Siam Pallet begins repurchasing broken pallets from their own customers. Clients are offered a significant discount on new orders if they return their end-of-life pallets to the factory. When those broken pallets return, they are fed into an on-site industrial crusher to be broken down into raw material. The engineering team then develops a precise blend, combining 50. In the B2B sector, this system also unlocks a competitive green premium. Many multinational corporations now have mandatory environmental supplier targets. This closed-loop system allows Siam Pallet to win large contracts that their linear competitors cannot even bid on. A circular model isn't a charity project. It is a competitive moat that secures cash flow. Pivoting to circularity is a high-risk move. If it is executed without operational discipline, it will rapidly destroy cash reserves. We must apply the lens of a diagnostician to stress test readiness before investing. We differentiate between external waste and internal inefficiency. If a factory has high defect rates, recycling scrap is just a band-aid. It must achieve near-zero defects before closing the loop. We also have to look at the product engineering node and evaluate design for circularity. Products relying on industrial adhesives or composite materials are nearly impossible to separate at a POSIT. To succeed, products must be designed for easy disassembly. Sustainability at scale is impossible to achieve if it is built on top of an inefficient internal process. Then there is logistical risk. Moving goods forward is a highly optimized science. Moving goods backward is fragmented and expensive. The math must be precise. Does the recovered material's value actually outweigh the cost of fuel and labor required to retrieve it? While consumers may pay extra for sustainable options, B2B clients optimize for cost. The circular system must be more efficient than the linear alternative. There is also the risk of greenwashing, the attempt to claim total sustainability while only recycling a fraction of your output. Modern investors and B2B clients perform rigorous environmental audits. Failing one of these audits can destroy a brand's reputation in a single reporting cycle. For circularity to work, it must be profitable at the unit level and transparent at the corporate level. These operational realities are now reaching the highest levels of global finance. Larry Fink, CEO of BlackRock, states that climate risk is investment risk. Institutional capital will be increasingly withheld from companies without a sustainable architecture. Operating within a circular loop has become a mandatory standard for industrial output over the next decade. Companies that master the loop will control their supply chains and their margins. Those who remain on the line will be priced out of existence.